Welcome back. This is the second video on molarity, and we're going to start delving into the math and the algebra of molarity. So molarity, as I said before, is defined as the number of moles that go into 1 liter of solution. That is the recipe. You can scale it accordingly, and I went over that in the last video. So here what we're going to do is look at how you solve using the math. So there's 3 components to molarity. There are 3 variables. You've got molarity defined by the letter M. You've got moles, and you write that as MOL. And then you've got liters. So mathematically, molarity is equal to moles divided by liters. And it's important to keep the units as liters. It can't be anything else. It can't be milliliters, for example. So what I've done is I've modified this a little bit in case you have a tough time with isolating variables. And what I've done is I've actually created this little triangle. And in this triangle, C is molarity. A represents moles, and this is actually an important component of this entire equation setup, and B is liters. And it's important, this cannot be in milliliters, it must be in liters. So C represents molarity, A represents moles, B represents liters. And this setup I find helps folks calculate the different components of molarity. So this is more from a testing perspective and being able to solve problems. So I'm going to use my little trusty little lens cap. So let's say you're trying to solve for molarity. Okay, so you're going to cover what you want. Once you cover that, you are going to take the moles and you're going to divide it by the liters, and that will give you molarity. If you're interested in finding out the moles, you cover up moles. C multiplied by B will give you the number of moles. So in order to calculate moles, if you take molarity and multiply it by liters, right here, you're golden. So molarity multiplied by liters will give you moles. And this is a very important component, and I'll talk more about it in a second. So again, and now if you wanted liters, you cover up liters again, so that's what you want. And you are going to take the moles and you divide it by the molarity, and that will give you the number of liters of solution you have. So again, in this triangle business, you cover up what you are looking for. One more time, cover up molarity. If you're looking for molarity, moles divided by liters. If you're looking for moles, molarity multiplied by liters. And if you are looking for liters, it's moles divided by molarity. So this is an alternative way to try and keep the variables straight while you're solving some of these problems. Okay, so I mentioned that moles are a very important component of all of this. So this is a very important component, and I'll tell you why in a second, because this is super duper important, very important. And so let me bring you this amazing graphic to talk about that. So moles lend themselves to solving for grams. So from moles, you can calculate the grams. This is important because if I ask you to make a solution for me in the lab, and you go into the lab, well, on a scale, it's where you're weighing out some powder to put inside a volumetric flask. Well, the scale is not going to, the measuring, the balance or the digital scale is not going to have units of moles. It's always going to have grams. And so you need to be able to convert moles to grams. Again, there's a video on that. You can go back and watch it if you'd like, if you need a refresher on it. The other thing is, moles can also be converted into particles. So this is Avogadro's number. We know that 1 mole is equal to 6.02 times 10 to the 23rd. This is equal to 1 mole. So here again, super duper handy. So moles, all roads lead to moles. See what I did there? I'm a poet and I didn't even know it. So again, solving for solving for A in this little mnemonic, for lack of a better word, that I've got. I call it the CAB system, C-A-B, cab as in taxi. It's very important that when you lay this out, the C is on the bottom left, A is on the top, and B is to the right. Concentration, moles, liters. You solve for moles. The moment you solve for moles, you can then actually convert from moles to grams. You can also convert moles to number of particles, or remember 1 mole is nothing but Avogadro's number. So you can use that to leverage the number of, if you're solving for the number of particles in a solution. Lastly, now we haven't talked about this, but moles can also, when it comes to gases, 1 mole, you can convert moles to volume. And this is only true for gases. So 1 mole is 22.4 liters is equal to 1 mole. And we haven't yet covered that, but it's for a gas. So solving for moles is super helpful. So just to recap, when you're solving molarity problems, you're always trying to figure out how many moles, how many liters. So you've got 3 variables. If you're given 2 of those 3 variables, you can solve for the 3rd. If you are asked a question or you're asked to make a liquid, to go and make a solution of a given concentration, well, you can do that, but you'll first have to go through moles to get to the grams. If I ask you a question about how many particles do you have in the solution, here again, you need to first figure out the moles, and from the moles then you can jump to particles as I've just shown you right here. So it's very, very crucial that you understand the concept of moles and how you can flip to grams, or how you can flip to the number of particles in a given solution. So this is just a very brief introduction to using a method to solve the math components, the math problems. I call it the CAB method, and I hope you found that helpful. Okay, so till the next video, bye.
Funny how the story goes, little hope but bigger dreams. They try to bring a sucker down, singing louder than the crowd.